Good morning. So this is our last Monday of the school year, and I don't think any of us thought that this is the way the school year would end. Unfortunately, it has, and I really hope next year doesn't begin this way. But I'm very proud of you for all that you've accomplished through this. This has been a very difficult time for all of us. So today is our last set of what I'm going to review for factoring. And that's difference of squares. And what that is, we'll review that today. Wednesday, we'll kind of just review everything together and be finished up for the year. So, difference of squares. Let's talk about that and review that. All right, so how do we know when to use difference of squares? Because that's always important about when we put all of this together. So when it has two terms, has to have subtraction. And those two terms have to be perfect squares, meaning I can take the square root and I don't get a decimal. And remember, with variables, to be a perfect square, it has to have an even exponent. Alright, and so how do we do that? So it looks something like this is kind of our rule. We have two things that are perfect squares, and they're joined by subtraction. And the way that they'll always factor is into two binomials with different signs, so we don't have to worry about the signs on this. And then what goes in the first here and here are whatever the square root of a squared is. So when we take the square root of that, we get a. So that square root goes there. And then for the last two, so it's the exact same thing that goes there, and then the exact same thing will go in the other two, and that's the square root of b squared, which would be b, and that would go here. So let's look at examples with numbers and things so we can see what that means. Alright, so let's say we have x squared minus 9. So first of all, it's a difference of squares because it has two terms. It has subtraction in between. And x squared has an even exponent, and 9 is a perfect square. So what we do is we put our two sets of parentheses with opposite signs. The square root of x squared is x, and the square root of 9 is 3. And that's all we have to do. So let's say we have x squared minus 100. Two parentheses, it has both, that's an even exponent, 100 is a perfect square, it has subtraction, so we put opposite signs. The square root of x squared is x, the square root of 100 is 10. Okay, so we got a few more examples. Let's say we have 16x squared minus 25. It's not always going to just start with x squared, but there are two terms, subtraction, and all of these things are perfect squares. So we put our two sets of parentheses with opposite signs. The square root of 16 is 4. The square root of x squared is x. So in the first term, I'm going to put 4x. And then the square root of 25 is 5. So I'm going to put 5 for the last two terms. Alright, let's say we have x to the fourth minus 4. This is also a perfect square because it has an even exponent, it has subtraction, and 4 is a perfect square. So two parentheses, opposite signs. Now, to take the square root, you just take that exponent and divide by 2. So 4 divided by 2 is 2. So x squared and x squared would go there. And then the square root of 4 is 2. And then we're finished. This is not a difference of squares because 2 is not a perfect square. So these are all difference of squares. Now let's talk about things that look similar to difference of squares but aren't actually difference of squares. Let's say it's addition. Okay, so if I had x squared plus 9, it doesn't meet the guidelines here for difference of squares because it doesn't have subtraction. So if it doesn't meet these guidelines, then we put prime. That means it can't be factored. Okay, so if we see a plus sign, we're going to put prime. So if I have x squared plus 25, that plus sign tells me to put prime. Okay, because they look just like a difference of squares, but it has plus. Here's another way that sometimes difference of squares can be a little bit confusing. So let's say we have x squared minus 5. We have two terms, we have subtraction. X squared is a perfect square, but 5 is not a perfect square. If I take the square root of 5, I get a decimal. So if these are not perfect squares, then we put prime. So that 5 made this one prime. Okay, so you got to be on the lookout for those, because sometimes in problems where we're factoring difference of squares, you'll get some of these ones that are kind of hidden that look like perfect squares but are not, and they're actually prime. We can't find factors for them. So today we're going to practice this. Wednesday we'll just practice all the factoring methods we've reviewed, and then we will be finished up for the year. Bye.